Thunderbit is also a newer bipolar, but it has what is called ultrasonic with it. So this was about the different aspects of electricity. We'll now quickly go with ultrasonic. Help me with ultrasonic. So another part of the energy, or another energy, is ultrasonic energy. Ultrasonic energy is not electricity. Electricity is only till it reaches here. In this handpiece, there is no more electricity, but there is vibration. So what happens in ultrasonic is you are going to get the same effect. You can see here, you can actually now cause the cutting. I'm cutting through. You can cause burning. Right, so if you see closely, I am actually causing a burning. See, that's a burn. So this is a burn, but it's not because of electricity. It's only vibration. So the question is, how does this vibrate? It vibrates in and out, not a lateral. It's not this way, it's in and out. And this vibration is at around 55,500 times per second. There is no electricity involved, as we have said, only frictional heat. So when you activate it in air, there is nothing wrong, it will not do anything. So for example, if I do this, I can actually see, I can touch it. The problem is, if I put that and I put pressure, it will cut my finger. So without pressure, it's just vibrating. It is this small straight arm which is the active arm. This one with the Teflon coating is the inactive blade. So the active blade can be used even to pierce, for example. You can see it is there, it will go in, it will pierce, it will go in. But this one does not do anything. So ultrasonic energy can be used to coagulate as well as cut. There is what is called the min and the max. So minimum setting can be between 1 and 3, and maximum setting is at 5. So this is a traditional ultrasonic. The difference in the two is how far this blade comes out. So the excursion of whether it's that far, or whether it's this much, or whether it's this much. So the lesser it is, the more the likelihood of it causing only friction little and causing heat to cause coagulation. When it goes very, very far, it has a higher chance that it will cut. So if you want to cut, you can actually cut with the maximum. You can coagulate with the minimum. So that is coagulation. But if you know how to use this instrument properly, you can actually coagulate even with the maximum. So how would that happen? It would happen with understanding that the pressure applied will be different. So when I want to coagulate even with the maximum, I would be applying just superficial, say that is coagulating, coagulating, coagulating. And when I'm ready to cut through, then I cut it and put pressure and it cuts through. So the difference is not in the speeds of the movement, the difference is also in pressure. So when you apply pressure low, it will be only basically coagulating. And when you apply it full and close the ratchet, it will actually cut through. So this is about ultrasonic. The one thing about ultrasonic is, yes, it does have, it's a very versatile dissector. It really helps with the vibration and creates a cavitational effect which will cause and help with further dissection. It is a good grasper, it is fine, it is good for coagulation and cutting, so you don't have to remove, going with scissors, put in bipolar, going with scissors, put in bipolar. But there is one negative about this, and that is that this instrument gets very hot at the tip. So when I've done this, and I've cut a tissue out, and especially if I activate it while it was touching this blade here can get as hot as 400 degrees Celsius. And touching this blade here to any surrounding structure at that time by mistake after buzzing, even if you've not activated it, is enough to immediately cause a hole into that tissue. So if that is bowel for that matter that is lying around there, imagine you've activated, you've done your dissection, you remove it, put it on this side, continue mobilizing things there, but this is touching bowel, you've caused a hole in the bowel. So the problem with this instrument is you have to be careful, you do not touch anything soon after you've applied and used it. Secondly, minimize activation when there is no tissue between the two blades. So the moment it goes through and you have cut it and it's touching the Teflon blade, stop activation, because when it touches the Teflon blade, it will definitely cause a lot of heating. I was talking about, so you can see, reduce that to 1, the 3 to 1. So you can see when I go 5, this is what happens. So you can see how quickly it is vibrating, and see what happens when the other one is there. So the difference is in how fast this one vibrates, you can see, and this one. So the effect is mainly with vibration of that plate due to the piezoelectric crystals that are in there, but the piezoelectric effect and the quartz crystals, but the effect that you want to get can be with the same, and with the minimum and maximum settings, it would still be okay. I think that is basically what we were trying to discuss about the monopolar and the bipolar and the harmonic energy sources. Thank you. Now, if I want to, one more thing about the harmonic. If I have a vessel that I want to cut, and remember this can cut quite a big vessel. So, if I want to cut a vessel, I would activate either with the low and cook, not put too much pressure. Then I actually have to turn the instrument and hold the other side, so cook from the other side. And then, once I've done both sides enough, I would then activate very fast and cut it through by putting pressure. And there it is. So, for cutting a vessel, especially big vessels, then you would have to cut, cause friction and burn on the top, cause friction and burn on the lower part, and then cut through. Alternatively, I could actually not use minimum, and I would still use only the maximum, but I would put less pressure, burn this side, I would put less pressure, burn this side, I would put less pressure, burn this side, and once I'm ready, then I would press this and cut it through. So the important thing that I'm trying to say is change the direction, use a low pressure grip initially to cause burn on the top, cause burn on the bottom, after you've skeletonized the vessel enough, and then cut it through. If you want to be even safer, do it on one side of the vessel, a little bit on the other side of the vessel, both sides, and then cut in the middle. So that way you will have very less chance that there will be a leakage of the vessel opening up again. If you don't see a vessel clearly, it is not very safe to use harmonic in the blind. So don't go grasping with the harmonic into the blind where you cannot see the actual sputter. If you don't see the proper vessel, then you're safer off removing the harmonic, putting a bipolar, and then buzzing it with a bipolar. So harmonic can be used for vessels, yes, but make sure that those vessels are clearly seen and you can hold the specific vessel and cause burning on both sides and it will stop bleeding. But if it is somewhere that's not clear, then you're better off with the bipolar instrument instead. Thank you.